So I'm talking here. Technically, the bulk of the job was done by Deepasis, our colleague from Lightband, and this is the work of many of the members of Fast Data teams. I'm here because I'm was the first one that was so disgusted by using Kafka Streams, Java APIs, and Scala, and this is kind of started the whole work. But before we delve into API, let's start from the beginning. So this all started because we decided that we need to be able to process streaming data, and if you manage to attend the previous talk by Duncan, who is sitting here and presenting that he doesn't hear me, he was talking a lot about importance of streaming and everything else. And I think this statement emphasized the importance of streaming and explains very well why we care about streaming. So when it comes to streaming, we have two options. As Jay Krabs was putting it, there is a traditional way, which is kind of MapReduce way, which is based on stream processing engine, and there is more, the way he called it, hipster's way, using microservices to do streaming data processing. And the theory behind this is that when streaming actually started, the first streaming engine that I'm aware of is Storm, and this was created at the time when MapReduce was very popular, and everybody was on the assumption that you are dealing with a lot of data. You need the real server that is managing instances and doing a lot of things for you. But and this was in part driven by Lambda architecture that was introduced by Nathan Mars, because the thought process was you're doing batch, and this is your main workhorse, and streaming just supplements it. Our industry is moving very fast, and very soon after Lambda architecture, there appeared CAP architecture that was saying, well, if your streaming is good enough, you don't necessarily have to do the batch to supplement it. You can just piggyback of streaming for everything. And this is where people started to realize that when you're doing streaming data processing, you don't have to deal with this huge corpus of data. You're typically dealing with either micro batch, as Spark does, or small windows, or even individual messages. And it turns out that NGM solutions are good enough for a lot of streaming application problems. And that's why the second option is Stream Process Library. So which one should you use? Well, SPE is a good fit for the applications that require features that are provided by stream processing engine, and most notably these features is scalability, restartability, failover support, all these good things that we are taking as granted. The caveat of this is, if you're doing this, you have to have a team maintaining the server, you have to adhere to their programming model, you have to adhere to their deployment model. On another hand, if you are using lightweight libraries like Kafka Streams, you write your code pretty much the way that fits your problem best, but you have to deal yourself with the infrastructure concerns. So, Kafka Streams, how many people in the audience know or used or hate or love Kafka Streams? Okay, so quite a few. But just a reminder. So Kafka Streams is a client library for processing and analyzing data using Kafka. It provides all the fashionable stream processing concepts, properly distinguishing between event time and processing time, windowing support, etc. And it provides simple and efficient management of the application states based on the stream stable duality. It looks absolutely great when you try to use it for the first time. It has its own quirks because if you know the tables are backed up by queues and they are using Duncan's favorite event sourcing, which works great with one little problem. If you're writing a lot to the table and you're trying to restore the table from the application that was up for the couple of days, it can take 10 to 15 minutes to restore the state. Always drives me insane. One of the examples where the solution doesn't really fit the problem, but using Kafka for everything was great. So the other thing is fairly low overhead. It provides additional integration with other systems except for Kafka, leveraging Kafka Connect. Again, theoretically it all works great. Practically, if you try to integrate Kafka Connect with Kafka Streams, you're up for a few unpleasant surprises. It doesn't quite work out of the box, but in general it works. Support for scalability and load balancing based on Kafka partitioning. I think you guys should know what this means. I mean, basically, if your topic has 10 partitions, you can have up to 10 independent listeners. Each one will be assigned its own partition. If you have less than 10, then some of the consumers will be assigned additional partitions. If you have more than 10, then some of the consumers are going to be idle. So when you are thinking about deployment, think about the amount of partitions that you are dealing with. This is where stream processing engines are so effective, because they basically look at the topic and then they say, okay, it has 10 partitions, I'll start 10 executors. Here you have to manage this by hands. The other thing, if you haven't tried it, I strongly recommend trying Queryable state. This is very, very convenient concept which allows you to take a peek into what's happening within the application, because Queryable state allows you to query Kafka Streams application, and if it is written correctly, you can see what exactly is happening. The last thing is Kafka Streams provide SQL interface. But unfortunately, at least from my point of view, the SQL interface is not part of Kafka Streams. It's a separate application which you have to write separately, so you can't really use SQL inside Kafka Streams application to transform the data. So what Kafka Streams is good for? ETL is very easy to write using Kafka Streams. Aggregation, you leverage K-table and it becomes really easy to write the aggregation. The nice thing about Kafka Stream is it employs to the largest extent stream table duality, so the APIs are exactly the same whether you're working with the streams or with the table. Flexible integration model, you can do in-memory integration, and I'll show a very simplified example of this, or you can do integration over Kafka, having one Kafka Streams reading one of the topics, processing data, writing to another topic, so that you can string together multiple Kafka Streams applications to achieve your overall goal. And then it supports effectively one semantics. This is one thing that bothers me significantly, because if you guys are following Kafka carefully, they've now introduced transactional semantics, and I'm just not convinced. Let's put it this way very carefully, because they kind of implement two-phase commit, but this two-phase commit is only on the same Kafka cluster. So I am starting to question the sanity of our industry. Kafka Streams APIs. Up until now, it only had Java APIs, but if you look at Kafka Streams, although they emphasize mostly DSL, in reality they provide two types of the APIs. One of them is process topology, which is kind of similar to what Storm used to do. And the second one is the DSL that they mostly promote, which is based on the collection transformation. The same thing that is done by Spark, the same thing that is done by Flink. Although they promote DSL for the most part, there is quite a few applications where usage of the process topology can lead to by far more efficient applications. So what's process topology? So this simple picture shows it all. Basically, you represent your application as a set of connected processors, and you just connect them by name. And Kafka internally builds topology, and everything works fine. So if you write process topology using Java APIs, it looks something like this. You write the definition of processors, and then you connect them together. Very simple, very straightforward. It's completely up to you what you write within the processor. So it's really a very powerful model. So if we try to use these APIs in Scala, well, look, it looks pretty nice. You don't really have to do anything. It looks as nice as the Java APIs. So it's exactly the same syntax, and we don't need to do much. When it comes to the DSL, the story is a little bit different. So DSL is abstraction for streams and tables in the form of KStream and KTable. So it's declarative functional programming style, and if you look at Java code, it looks quite nice. So it's very fluent code. There is nothing wrong with this, and everything is very beautiful. But if you try to use it in Scala, and this was the main driving factor for me, so the initial definition looks fine, but then you get this ugly thing, because you have to explicitly specify the type of everything. And everybody who ever tried to do it or look at it just turn around in disgust and use Java. Well, this is bad, but this is even worse. So you can't really do any transformation. For every transformation, you have to write something like this. So what's the problem? It's very simple. It's type erasure. So the idea behind Scala library was very simple. beta type inference, less boilerplate code, usual builder style, implicit serializers, and beta type safety. Let me explain one more thing here. So when we started talking about Scala APIs for Kafka Streams, the group of 6 people split in about 5 different camps. Because my take was, let's just preserve what they have in Java and make it usable for Scala developers. So no syntax improvements, nothing specific. And the driving factor behind this was the fact that they evolved their Java APIs, and we shouldn't create incompatible model. The other 4 groups were proposing functional changes to the APIs, semantic changes to the APIs, and for one of the few times in my life I won. Maybe because I had the loudest voice, but the overall design is basically mimic the existing Java library with the beta type inference and all other goodies. So the idea behind the library implementation is very simple. It's just wrapping the existing Java APIs, exposing the same semantics in the Scala syntax. The other thing that it relies heavily is implicits for the conversion. And finally, more implicits for functional conversions to allow for SAM type support. So once this was put in place, we can return back to our original example, and this looked good from the very beginning, but this looks by far nicer. And effectively, what you see here is pretty much the same Java code with the Scala syntax. And this was one of the driving factors, because you can pick up Java documentation and you can use it for Scala directly. It works out of the box. The code looks nice and clean. So after this was done, we've also decided to improve one more thing. And this is dealing with SerDes. You guys know what SerDes are. Serializers, deserializers. So Kafka internally stores everything as byte arrays, which means that in order to get data in and out of Kafka in a very in any meaningful way, you have to marshal and unmarshal this data, and this is the job of serializers and deserializers. And if you look at the Java APIs, it has SerDes sprinkled all over the place, which is okay, but could be improved. So one thing that we've actually improved in the Java APIs is introduction of implicit SerDes. So we decided that this was really ugly and not type safe. This is how Java does it. So instead of this, the Scala library does this. So it just introduces implicits for everything that SerDes are doing, and now you don't even have to use them. They're hidden from you. So instead of hoping that you've done everything right and explicitly writing serializers, deserializers all over the place, the Scala library is doing implicit, so you have guaranteed type safety, and you have by far less boilerplate code. So with this in place, this is how everything looks like. So this definition just disappeared from your code, which make it simpler and nicer. And if you don't have serializers for something, then Scala compiler will scream at you really loudly, and you will know that you have to add it into implicit, and it will tell you where it is missing. So as a result, this is how the APIs are looking like. So implicits are already in place by Scala, and the only thing that you have to specify are the variables that you need. And with this, the application code is looking even more concise. So this is basically why we're doing it and what's the advantage of doing it. And even Scala guy is knocking his head saying, yeah, it's the right thing to do. Okay, so this is for the standard service that are provided by Kafka Stream. What if you have to have your custom ones? Well, it's exactly the same thing. You just have to implement your own service, and you have to write your own implicits. And this is how this is done. So when we were moving this code to Kafka, they insisted, for some reason, these people are in love with Avro. Beats me. I'm still trying to figure out why. I was trying for the last year and a half, and I still don't have an answer. But it was mandatory for us to show how Avro served. What's funny? You guys are big fans of Avro? Okay. Yes, I'm not the only one. So it was mandatory for us to provide the example with the Avro Serdi, and this is why it's here. And this is how the code looks like with the custom service. So it's the same clean code, you just have to implement your own serializers, deserializers. Okay, so this is for DSL support, but as I mentioned, there is one more feature in Kafka Streams that I'm particularly fond of, and this is queryable state. And this diagram basically illustrates the advantages of using of the queryable state. You don't have to have an additional database on the site. You don't have to send data back and forth. You can just query directly the current execution of Kafka Streams, and get everything that you need. So details, remember I was talking about the fact that Kafka Streams application allow you to scale. If you have multiple partitions, you can have multiple instances of the same Kafka Stream application that is doing exactly the same thing. So when we talk about queryable states, there are two things to consider. There is a local queryable state, which is completely property of the running JVM. And there is remote state if you have multiple instances of the same Kafka Streams applications. In order for you to be able to reconcile, you have to talk to all the instances. So Kafka Streams natively provide all the required functionality for the local case. For the remote case, they are basically saying, well, it's not so hard, and this is how you implement this. you basically have to implement a RPC layer that talks between the instances and allows you to get the information. Well, and they provide the sample code. When I first looked at the sample code, I'm old enough, so I still remember what the squiggly get is and what the squiggly path is. It's, if you guys don't know, it's JAX RPC, JAX RS. A lot of guys on our team were just looking at it saying, what the hell is that? We've never seen this thing before. So this was not the only thing. You have to write quite a few of the boilerplate code to make this working. So we decided that we absolutely don't like it. Besides, we work for lightband, we own HTTP, we can do things better. So this is the second library that we have created, which is a library for queryable state. So it basically organized in three main components: HTTP services and serializers. And those are the main classes that are provided. And with this in place, yeah, this is much nicer, more readable code. So basically, we were trying to attack both sides, how you write Kafka Streams implementation using Scala and how you use queryable state. We also did a couple of provisions for distributed query handling because we need to support multiple physical machines. We need to query all them to support, to combine together all the local states. So the query service interacts with Kafka Streams metadata service, which returns you back information about all the active nodes. So now you can query each of them and you combine things together. The other thing is, in order to make sure that if you redeploy and some of your partitions will move to the different machines, we put invalid state exceptions, so we added a little bit more robustness for you to deal in a distributed case. So where are we with this right now? So Kafka Streams Scala. We didn't invent this thing. It was actually originated by Alexis. Okay, I'm not going to butcher his last name, but this was the first thing that came up during the initial search, but his implementation was completely rewritten. The ideas were kind of similar. The implementation is quite different. We've internally have this in version 0.1, and you can download it from Lightband GitHub. We've also worked with Kafka community quite a bit, and we went through Kafka improvement requests, and it was accepted. And finally, I'm happy to tell you that it is part of the official Apache Kafka library. So you don't have to go to us, you can go to Apache Kafka source and download it from there. I know that our code had Maven support. I don't know whether Apache code already has Maven support. You might have to wait for the next version of Kafka release to have Maven support for this library. But if you go to ours, it's in Maven, so it does work Fine, and Kafka Stream query is only our library because Apache Kafka was not interested in this. They were saying, well, we're not defining how you guys do this. It's completely up to you. So we're maintaining it internally inside Lightband. It's still in version 0.1.1. It's available from our GitHub repo, which is opened, and it's also available in Maven. Pretty much the same thing, and considering that this is the last presentation of today, I figured you guys are willing to explore Berlin or do whatever you want to do. So we are finishing a little bit earlier, so if you have any questions, go ahead and ask them. Other than that, I'm done.